When the floor or the ground is too slippery, it is too smoother, we will be not able to walk on that floor. So in that case, what we can do? We can sprinkle some sand so that the friction can be increased. If a body is executing uniform circular motion, the net inward force is called as centripetal force. For a given value of mu s and r, the maximum speed of circular motion is nothing but v is equal to root of mu s d into r. Hello everyone, welcome to session 3 of chapter 5 Laws of Motion. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in this chapter, we have discussed till now about the Newton's laws, the 3 laws of Newton and the significance of these 3 laws of motion and about the friction and many more. So in today's session, let us now study about the methods of reducing friction. In the last class, we have studied about what is the meaning of friction, what are the causes. Yes, when one body is in contact with the other body, the opposing force that acts between the surface of contacts is called as a frictional force. Now, how to reduce this friction? That is what we are going to discuss now. Friction can be reduced by polishing. Yes, by polishing, we can make the surface softer or smoother, and so that the friction between the surfaces can be reduced. So, polishing is one of the way to reduce the friction, as well as lubrication. That means applying oils or grease. So, applying all these lubricants, what we can do? We can reduce the friction between the surfaces, and also the selection of anti-friction metals. Friction also depends on the nature of material what we use. So, by selecting anti-friction metals, we can reduce the friction, and using ball bearings in machinery parts, by using ball bearings, we can give the smooth flow of the machines so that the friction can be reduced, and also streamlining. By designing the vehicles streamlined, we can also reduce the friction. So, these are the few methods to reduce friction. So, next we have friction can't just be reduced, it can also be increased. When the floor or the ground is too slippery, it is too smoother, we will be not able to walk on that floor. So, in that case, what we can do? We can sprinkle some sand so that the friction can be increased. And also, in the automobiles, by using synthetic tire, the friction can be increased. And we do also have so many methods to increase friction. So, not only these two are just an example. We do have so many methods to increase friction. So, next topic we are going to study about the centripetal force. What is a centripetal force? Imagine if a body is traveling in a circular motion, there is a radially inward net force which is always attractive, or which always directs the body towards the center, and that force is called as centripetal force. It is nothing but the radially inward net force that acts on a body executing uniform circular motion. If a body is executing uniform circular motion, the net inward force is called as centripetal force. Or any motion in a curved path represents accelerated motion and requires a force which is directed towards the center. We will call it as the centripetal force. So, it is given by the formula Fc is equal to mv square by r, where m is the mass of the body, v is the velocity of the body, and r is the radius of circular path. So, how did we get this? We know the formula for force, that is mass into acceleration, but the centripetal acceleration is given by a is equal to v square by r. Substituting the value of this in the equation, F is equal to ma, we will get F is equal to m into v square divided by r, and that is the expression for centripetal force. So, next we have centripetal acceleration. So, it is nothing but the acceleration that acts on a body which is executing uniform circular motion. It is given by the formula AC is equal to v square divided by r. So, now we are going to study about the applications of circular motion. What are the applications? So, the circular motion, we will all have a daily life application. Now, we are going to discuss few applications of circular motion. So, the motion of a car on a level road, if a car is undergoing circular motion, but the road is so leveled. So, in a level road, the motion of a car can be calculated and the maximum speed of a car that is given by root of mu s d into r. This is the maximum safest speed of a vehicle which is traveling in a level road in a circular motion. So in this expression, Vmax is maximum speed of a car and mu s is coefficient of static friction, g is acceleration due to gravity and r is radius. So from this above expression, we will come to know that the maximum speed or the velocity of a car does not depend on its mass. It depends only on the coefficient of static friction, the radius and also the acceleration due to gravity. So based on this idea, so now let us derive the expression the maximum safest speed for a car which is traveling in a level road. So this is a derivation of motion of a car on a level road where we are going to find the expression to calculate speed. So here consider a car of mass m going around a curve of radius r. You can observe here we have considered a car m which is going around a road in a circular motion. The radius is given by r with constant speed v on a level road. Here there are various forces that acts on a car. So what are these various forces? That is, one is nothing but the weight of a car. Weight of a car which is acting downwards, that is given by W is equal to mg, and also we can observe here the net upward force, and that is called as normal reaction, and there exists a frictional force between the tire of the car and the road, where the tire and road surface are the contact point. There exists a friction. So there are totally three forces that acts, that is weight of the car, W is equal to mg, normal reaction and frictional force. As there is no acceleration in the vertical direction, here n and mg are balanced with each other. So we can say that n equals mg. There is no vertical acceleration. Here, when the car is traveling in a road, no vertical acceleration and the normal reaction will be equal to the weight of the car, and hence we can write n is equal to mg. Let us take it as equation 1. So in order to have circular motion, centripetal force is required. So this centripetal force should be balanced by the static frictional force. So where is this static frictional force exists? It exists between the car tires and the road. So this static friction opposes the tendency of car moving away from the circular path. So because of static frictional force, the car will be moving and this force is always directed towards the center. Because of the presence of this static frictional force, this force will avoid the tendency of car moving away from the circle. So what is this centripetal force expression? It is given by F is equal to mv square by r, as we all know. So I'll take it as equation 2. Here in this expression, r is nothing but the radius of circle, and we know that the static frictional force, from the laws of friction we have learned this, that is Fs is less than equal to mu s into n. But what is n? N is equal to the normal reaction, which is equal to weight of the car, and that is equal to mg. So I'm substituting the same in the above equation, and we will get Fs is less than equal to mu s into mg, and this is from equation 1. So here substitute the value of f in the above equation, we get mv square by r, which is less than and equal to mu s into mg. That is from equation 2. Now we got these two equations. So let us now simplify for velocity. Look at this expression carefully. Here we have mv square divided by r, which is less than equal to mu s into mg. So now let us retain only v square here, and let us bring this mu s mg as it is. We have here retaining the same, r gets multiplied to RHS and it will come here, and m in the denominator. Now we can cancel m and we remain with mu s r into g. Since m and m gets cancelled, we get v square, which is less than equal to mu s into rg. So from the above expression, we can know that the velocity is independent of mass. We do not have any term of mass in the above expression. So we can conclude that the velocity of the vehicle does not depend on the mass of the car. So for a given value of mu s and r, the maximum speed of circular motion is nothing but v is equal to root of mu s d into r. So how did we get this? Here we have v square is less than equal to mu s rg. So the maximum speed is nothing but it is root of mu s rg from the expression. So what if the car exceeds this speed? There will be a sliding and the car will no more be traveling in a circular path. There may cause an accident, and this is the maximum safest speed for a vehicle while it is traveling in a circular path in a level road. So based on this idea, let us now study about the banking of road. What is the meaning of banking of road? Look at this picture carefully. Here we can observe that we might have all observed in our daily life also, whenever we are traveling in a guard section or in curves, so we can observe that the outer edge of the road will be raised up for little amount compared to the inner level. So here the outer edge of the road will be raised comparatively to the inner level. So this raising of road, the process of the raising the outer edge of the curved road above the level of inner edge is called as banking of road. So in banking of road concept, we must understand a term called angle of banking. How to define angle of banking? What is this angle of banking? So it is nothing but the angle between the inclined surface and the horizontal. So the angle between the inclined surface, because the outer edge will be raised, so that is called as inclined surface. The angle between the inclined surface and the horizontal is called as angle of banking. So let us now study about the motion of car on a banked road. Let us derive an expression for maximum safest speed for a vehicle which is traveling in a banked road. So here we know that the motion of car on a level road is Vmax is equal to root of Rg into tan theta. Let us now derive the maximum safest speed for the vehicle which is traveling in a circular path on a banked road. So for this, consider a car of mass m with moving speed v on a banked road with radius r. So let us consider a car whose mass is m, which is moving in a banked road with a velocity v and its radius is given by r, and theta be the angle of banking with frictional force F acting between road and the tires of a car. So here we are considering a banked road. You can observe there is an inclined surface and this is called as angle of banking, which is nothing but the angle between the horizontal surface and inclined surface. So we'll call it as angle of banking. Here the car is moving. When the car is traveling in a banked road, also there exists a various forces. One is the weight and the normal force. Since it is inclined, we can observe here the normal force exists, and this is again resolved into two components. One is n cos theta and the other one is n sin theta. Here third force that acts between the tire of car and the road is nothing but the frictional force. Here A is equal to V square divided by R is nothing but the centripetal acceleration. So you have to understand the diagram carefully to derive this expression. So there is no acceleration along the vertical direction, as we all know, and we have already discussed about this in the previous derivation. The net force along this direction must be 0. Since there is no acceleration in vertical direction, the total force, the net force must be 0. And from that we can write here the vertical direction, we have n cos theta, which is equal to the various force that acts downwards, that is mg plus f sin theta. So we can write n cos theta, which is equal to mg plus f sin theta, and I'll consider it as equation 1. The centripetal force is provided by the horizontal component. The horizontal component provides the necessary centripetal force, and the horizontal components are N and F. So the horizontal components of the normal force and frictional force are given by N sin theta plus F cos theta. So this diagram same is graphically represented like this. Here there is an action of frictional force as I have shown. This frictional force is again resolved into two components along x-axis and y-axis. So along x-axis it is F sin theta and y-axis F cos theta. Why I am showing this as x and this as y? Because the frictional force is in the third quadrant. So it is acting downward. We can say that. I hope the diagram is clear to everybody. So from this we can write the components of N and F along the horizontal is given by F cos theta plus N sin theta, that is N sin theta plus F cos theta, which is equal to the centripetal force, and that is mv square divided by r. That is our equation 2. So here in this equation, m is the mass of the vehicle, v is the speed with which the car is moving along the curve, and r is the radius of the path. So when the velocity is maximum, when we have a velocity, maximum velocity, we can say that the force of friction maximum, which is equal to mu s into n, this we got from the law of friction. So here, now first equation and second equation becomes substituting the value of f as mu s into n in first and second equation. So we get n cos theta is equal to mg plus mu s into n sin theta. Why? Because here in this expression, first equation we have f. So in the place of f, I am substituting mu s into n, and we get n cos theta is equal to mg plus mu s into n sin theta. Let us call it as third equation. Similarly, substitute the same value of f in second equation. Look at the second equation, we have n sin theta plus f cos theta. Here I am substituting the same, that is mu s into n, and I get n sin theta plus mu s into n cos theta, which is equal to mv square max divided by r, because we have considered when the car is moving in a maximum velocity. So we will consider this as equation 4 now. So now consider this equation 3. So from equation 3 we can get n cos theta minus mu s and sin theta. Transposing this to the other side, we get n cos theta minus mu s and sin theta, which is equal to mg. Take n common from these two expressions, we get cos theta minus mu s sin theta, which is equal to mg. Now bringing this term to the denominator, n is equal to mg divided by cos theta minus mu s into sin theta. Now from this we got n expression, terms for n, and substituting the value in fourth equation. So we get, in the place of n, substitute mg divided by cos theta minus mu s sin theta. So we get mg divided by cos theta minus mu s sin theta, that in the place of n, and sin theta as it is retaining, plus mu s as it is writing, in the place of n again, mg divided by cos theta minus mu s sin theta, and same here also we have cos theta, so retaining the same here, which is equal to mv square max divided by r. So now in LHS both the denominator values are same, so we can retain cos theta minus mu s sin theta, and in numerator I have mg and mg common in both the terms, so take mg outside and we remain with sin theta plus mu s cos theta, which is equal to mv square max divided by r. So now in these two expressions m is common, so cancel m, and we remain with g into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta, which is equal to v square max divided by r. Remember, here we are going to derive an expression for velocity. So in further simplification, we can retain the term of v and we can rearrange the other terms to get the expression. So we are now retaining v square max to the one side and bringing all the other terms to the other side. So we get rg into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. So now for the further simplification, divide the numerator and denominator of RHS by cos theta, and we get v square max is equal to rg sin theta divided by cos theta plus mu s as it is cos theta divided by cos theta whole divided by cos theta by cos theta minus mu s into sin theta by cos theta. We know sin theta divided by cos theta is nothing but tan theta. So replacing the sin theta by cos theta, we will get rg into tan theta plus, here cos theta gets cancelled and we get only mu s divided by cos theta get cancelled, 1 minus, here will remain with 1. So 1 minus mu s into sin by cos is tan. So 1 minus mu s into tan theta. We need only the velocity term. We have v square here. So let us simplify this by writing a square root, that is v max is equal to square root of this whole term, that is rg into tan theta plus mu s divided by 1 minus mu s tan theta, and that is equation 5. And this should be the maximum safe speed of a vehicle on a banked road. And if the speed is more than this, again we can say that the vehicle may get accident. So the maximum safest speed of a vehicle which is traveling on a banked road can be calculated by the above formula. If the value of mu or mu s is equal to 0, there is no friction action between the road and the tires. So the safer maximum speed will be given. So the equation 5 becomes v max is equal to root of rg tan theta if the value of mu s becomes 0. So this is the expression for maximum speed of a vehicle which is traveling in a circular path along a banked road. So from these things, what are the keynotes or the key points that we can remember is the maximum possible safe speed of a car on a banked road is Vmax is equal to root of Rg tan theta, and which is greater than on a flat circular road, because on a level road we know the safest speed of a vehicle is Vmax is equal to root of mu s into Rg. Okay, so from this we can conclude that the safest speed of a car on a banked road is greater than the safest speed of a vehicle on a level road. And also there the maximum angle of banking should be given. So from this what we can say that the minimum angle of banking should be there to prevent the tires of the vehicle from tearing. So in order to prevent accidents, the road should be banked at the curve for safety purpose, and that avoids the vehicles from skidding and overspeeding, and also we can safeguard the vehicles by getting accident. These are very necessary and the important points to understand in the study of this motion of body in a circular path, whether it may be in a level road or banking road. These are the points we have to keep in mind. So in today's session, we have learnt about the motion of an object in a circular path and what is the safest speed of a vehicle which is traveling on a level road in a circular path and also in a banked road. So in the upcoming sessions, let us learn more concepts regarding the topic laws of motion. Until then, keep learning all of you. Thank you.